I've got an example here where I've written some C code for a Cortex-M microcontroller and I've turned on full optimization. Now this code is somewhat contrived, but I'll just talk you through it. So we're reading data. Now data comes from a bus in up here. So the compiler cannot anticipate what that value will be. So this limits how much optimization can be done on this line. So we take data, which by default will be 0 at the moment, it'll add 4 to it, and then I set x to 0. And then inside this loop, which runs n times, now I would stress that n cannot be predetermined by the compiler, so we can't optimize that out. I'm going to go x equals x plus a function of n, and that function's up here, and all it does is it doubles the value. Now once we get to this point at runtime, we will know the value of n. So function of n will be a constant. So what's the point of calling it over and over again to just get the same value? Well, that will not go missed by the compiler, and let me show you that working now. So I'm going to step line by line. Now bear in mind, full optimization's turned on, so the debugger may leap around as it tries to match the actual code to the source code. So as we enter this loop, you'll notice something unusual. It branches straight to that function. So this is actually happening in a different order to what's being written. So although we're calling the function on this line, it was actually as we enter the loop. So we carry on and we run and we exit that one, and then you'll notice that we still go round the loop, but the function's never called ever again. So it's only been called once. So this was called once, the result was stored somewhere, and then that constant value is then added on to x each time. So this is an example of where the order in which code is run can be changed without changing the outcome of the code.